Alright, so I'm currently at home for the holidays, but I'm going to try and get some of this done because I've got some time whilst the rest members of my family that are currently home are watching football. So I'm going to try and get these two scary ones done. Probably be all I get to. And I know I've said I'm not going to use the alternate manuals, but given that I have never done missing sequence before, I'm going to be using this manual to at least give me an idea of what could appear, basically. So, I don't know how this is going to go, but let's just see what happens. Okay. So we got the line, which is 21, 31, 62, 25, 49, something. We then have cyan, which is 80, 95, negative 15, 110, something, 235. That negative 15 is confusing there. Magenta, we have something, so we'll go at the first one. 285, so that definitely looks like a sequence. 309, 313, 350. Interesting, that looks possibly to do with factors. Orange, we have 488, the number we need to find, 580 to 629, 680, 723. We need two more. We then have pink, we need negative that, negative this. The number we need to find, negative 817, negative 410, negative 37. And finally purple. We have 104, minus 127, 501, something, 048, negative 287. So given the pattern here, we know that this one's going to be negative. We'll probably be looking down here somewhere. So, yes, let's just get on with it. So this one, immediately see that this is just multiplied by 2. So, but this isn't multiplied by 2. Doesn't seem like it's Fibonacci. These are offset. Doesn't look like any of them. No. The changes are too big for most of these. Yeah. What I'm definitely looking at is this. Which of these would cause that one to just simply double? Some prime factors and offset? Could be. Actually, that does look like it, because that would be 10. Some prime factors of 31 are 31. I think so, at least. Is prime 31. Yeah. That'll be only 31. Prime factors 21 are 3 and 7. We would estimate 10. Prime factors of 62 would be 31 2. Yes. 95 prime factors 95 is 5 and 19 plus 5 plus 19. Yes. So prime factors of 119 are 7 and 17. So 119 plus 7 plus 17. We have line equals 1.3. The cyan one now. So this one switches sign suddenly. Guess we can look at the alternating sign one now. This is really tough. Let's look at this one because this looks interesting. The difference between these is 10. Between these is 14. 10, 14. Then 3, 1, 3. 3 and 9 is 4. So it's not some sort of thing like that. But like prime factors again. Is prime 1, 3. Yes. Then does that make sense? This seems like Fibonacci. Although actually this plus this positive is that this plus this, the difference between these two is 15. The difference between these two is 100. Oh, this could be the differences. It's just A minus B. Because 80 minus 95 is minus 15. 95 minus 15 is 110. So minus 15 minus 110 could be negative 125. Does that make sense for the next one? 110 minus 125. Yes, that seems right. And this one, this is the differences didn't look. They're not regular sequence again. I was about to say that it's decreasing, but no, this 10, 14, 4, 2. So some of the digits. That makes sense because that would be plus 15. Could any of these be some of the digits? No, because that change is too big again, I think. But interestingly, you get 580 and 680 there. Look at the differences between these ones. Can't check that one. Difference between these. Does seem to be alternating 3 and 7. 3, 7, 3, 7, 3. So it could be a specific offset to these offsets. Because that's the difference between these offsets. But we can't really check that one. 3, 3, minus like 4. And to get from here to here, 1, 2, 3 times. So well, these would be plus. That wouldn't make sense though. These are like geometric progressions. Could it be the set of perfect squares? That's close to 25. That's close to 26. Might be onto something here. That's close to 27. And they all seem to be off by roughly the same amount. So that would be minus 4. That's minus 4. That's minus 4. Okay, so we can find that one. The orange one is perfect squares. So 580 is 24. So we need 23 squared plus 4. We get 533, which is 23. And 488, 32, 533. Yeah, so 533 there. Okay, found that one. Don't think it's going to be the same with that one, the other one, so. I see. It could be perfect square. Obviously, we start from negative numbers. Maybe let's look at that. Switch to cube roots. 4 minus 157 over 1. No, for that one. It's not going to be square roots again. One of the things you might have to look at is the factors of these. Although I do need to check something of how does it work. But I guess the first few terms are just in there if you need the previous terms. I don't think it's a product of digits and offset. These squares as offsets, or cubes as offsets actually. If we took that looks interesting. Oh, the difference between these is 11. What about this and this? 12. Aha! These two seem to have cubes as offsets, I think. Because if we take a number, we add a cube to it, we took a different number, the same number again, but added the next cube onto it. When I've taken the difference, we're getting the difference between the cubes there. So that's 13, that's 12, that should be 13, and that should be 14. So this one should be 15. To figure out what that means. Yeah, so we have x, and we add a cube, and we add the next cube. Is that what it is? So when we subtract them, we just get the cube. The cube for this one. So going back to here, 104 plus 104 plus 1, 2, 7, 11. So 11 cubed, 1, 2, 1, and then 104 minus that, got that. But would it be minus 11? And we're adding it. The minus 1, 2, 7. Or is it just 11 cubed minus the previous number? And with minus that. Because then we have minus 167, 12 cubed. No. So we know what the difference is. So that was that cube. So 104 minus 131 is plus 12 cubed. Minus 11 cubed. So minus 13 cubed. Are we looking at minus 1696? Add 14. Add 14 cubed. You get that, yes. Then minus 15 cubed. You get that, yeah, okay. So that's that one. Still need to do 2 more. This magenta one is really getting annoying. I haven't even looked at the pink one yet. The pink one looks like a normal progression in some sense. Just what? Guess we could look at the factors. of some of these numbers. Factors of so here's the factors of this. The lag is causing some trouble. We take this. Yep, this. How close that was like, because it seems to be lagging. Anything here? $5.57, $5.59. Five times 61. No. Factor. Because it isn't that. And that won't make sense for the rest of them. That was just coincidence, I guess. So the difference between these is 10. Maybe we can get 10 from that. I take the differences between these ones. Yeah, something, something. Then I thought I minded that. Okay, these look interesting, but then this doesn't make sense. So the gap between these is much smaller. Anyway, because I've done this. We've done that. So but these look like fascinating numbers. These cubes? No. These aren't squares either, I'm assuming. No. So let's go with these instead. 407. And then 410. 37. Difference between these ones is -34. So could these all be minus 34? So this plus 34. We have minus no. Need to figure out how these numbers are related to each other. Mm. I think it's a plus b minus a times b. Either of these. This divided by 5. But we really could clarify this one's prime. So it's not really divisibility one for this. Yeah. These numbers aren't prime though, I don't think. Over 2 prime factors of 2714. 223 and 59. We have prime factors of this. 37. 2 plus 23 plus 59. Doesn't seem to be anything to do with that. Hold on. Is it going to be the same as all the other ones? No, the gap here isn't good, big enough. Yeah, neither of these. Although these are quite similar in themselves. It didn't continue though. Let's just check these. I think I've already checked this though. Yeah, because that would be 13, 12. Yeah, the differences aren't really similar either. What about these differences? No. Doesn't seem to be any sort of Fibonacci thing. Must be this. No. Could be the other way though. Maybe minus, I think. No. Don't think that was good particularly work for the other one either. Six, 5, 6, no. Can't be prime factor, I don't think. Prime factors of 3, 5, and 19. That doesn't seem to be either. Oh. Could be set primes with offset. That would explain like the sporadic differences. Because we know that's not prime, but that's prime. Okay, we might be onto something here. if we look at sequence of primes, prime checker, we have 283, 293,307. Yeah, this is looking possible. Yeah, this is just a sequence of primes minus. Yeah, that's that one. That's that one. So we're looking at 370 minus 2. We had this one, which was that one, plus 2, plus 2, plus 2, plus 2, and we want the one before this one, so 283. Is that one plus 2. Now we just focus on this pink one, which is really annoying. So it's not alternating sign, but it stays negative the whole time. Not going to be the product of the digits. I don't even know that's an option. To convert it not squares or cubes. I think at least. Negative 8, because this looks like it doesn't really work. Look at this again. Three something. 1943. Five and 41. these numbers look interesting. A7 is just A7, yeah. $37, 41, 43. Okay, these look like primes in order. So this one's going to have 47 in there somewhere. But what does it link them together? So we have this. How are these linked together? That's going to be 10, that's going to be 1 if we're multiplying. This would be, that'd be 46. Is it just minus 9? Minus 9, 28. It would be the primes. This is a sequence that goes minus 9, minus 9, minus 9, minus 9. Yeah. So we were looking for the third one. So, and it was negative, so that possibly. It would be, one of these was minus when we were multiplying them. Okay, I think we have an answer then. So, then looking at original method sequence manual to see how to input this. So the screen shows 6 colour rectangles on the estate, and their values have been defaulted to 0. Currently selected rectangles doing yellow. Right, enter the value. Press the grey button to navigate the value. Press the green button. Press green again to submit the 6 values. Correct, the module will solve, otherwise we will show the wrong ones. So, lime we got 143. Cyan we had negative 135. Magenta we had 283. Orange we had 533. Pink we had negative 1316. Purple we had that. So this is what we have. Chance we could have got one wrong. Maybe just by typing it wrong. Let's see. Oh, Jesus. Okay, that took about 50 minutes. Now time to get rid of all that and try to land Hypercube, which I've already set up the grid I saw in the condensed tutorial by Quinn West. Scroll down all the way here. Sorry if I'm talking quietly and you can't hear me properly, because I'm at home I don't want to make too much noise. Right, so we're here, and Hypercube. So we do X and Z in the grids, Y is down this side, and W is across this side. So the bottom, here we have the bottom cube. Got triangle cube. I think they put that as 2. Nothing else on the bottom here. We then have on the second row, we have quite a few. Well, quite a few, I mean 2. We have 4 there, and then also there. That's all that's there. The next row is just this one. That's number 3. And the top row is 3 there and 4 there. We then have, I was confused, I read the button for that one. Got 1 there, and we have 2 there, I think, or the 3 there. Yeah. The next row we have nothing. Then we have 4 here. The final one we have 2 or 3 there. We then have bottom row, we have this cube, and we have 2 here and 1 here. We then have the row above it 2 in exactly the same place, but that's 1 and that's 4. From the tutorial I found out that most of these are set up exactly the same. Oh, there's a cube above here as well. So these are set up in a way so the rows don't change between, like the thing you can use to work this out. So we have 2 down here. We have something on the second. That's this one here. That's 3. There. Second, we have up here we have a 2 and a 3. And then top we have 3. Yeah. So now we can fill in some stuff. So since I think the rows stay the same, I might quickly copy this and paste it in here. In case it's wrong. So if the rows are the same, it means that if the rows are the same, we can look where numbers are in the same place, for we know. So do we have any other 2s in the 3rd position? Yes, so that's going to be 3 as well. That one's going to be 3. Then you have 3s in the 4th position. No. So next, can we fill anything in? Each row, column, and stack in a rank of the grid may only contain one of each shape. I mean, that one has to be 3. That one has to be 4. So now we can look for 3s in the 3rd position. or 4th in the last position. Okay. We can then, can we look at anything else? Anything else that gives us a clue? So we know where the 3s are in both of these. You know, this is the 1, so we know the 3 has to go there. And this is 3, 4. So 3's in the 2nd position. Get a 4, I think. And then using that, the only place 3 is here. Meaning 1's in the 3rd position means 3 in the 1st position. Yeah. 3, 4, so 2 and 1 there. So 3, 4, 1. It would actually take 2 there. So now this entire thing can be put here. Hang on, that's not the words anymore. That. 2, 3, and 4, so that's 1, that's 2. So everything that fits this. So this is 1, 2, 3, 4. That's 1, 2, 3, 4. That's it. That one's 4. Meaning you have, I think that fits this, 3, 4, 1, 2. But that's 3, 4, 1, 2. That's 3, 4, 1, 2. 3, 4, 1, 2. 3, 4, 1, 2. And then that's 4 and that's 1. So we can just fill in most of the rest of it now. Where we need spaces, so that's there. This one is there. So this is the row layout for each one. We just move these where they need to be. So that's up there for the start. Just to make sure seems right. For second. 2 first. Here you got all of these filled in above this one. So yep. We've got all these filled in, now we can logic out where the rest is meant to go. 1's there, so that one has to be 4, I think. So that one's 4. That one's going to be 2 at the start. This one has to be the only one that hasn't been used here. So that would be 2, 1. So And then I think we can get to the point where all the cubes also look the same. All the layers of the cubes look the same. We have this, doesn't do anything. So we can take this, move it there, this, move it there. Then we can do that same here. We only need to fill in half of it, so we're looking to get these top ones filled. This one is just going to be the same as this one we figured out. I think this is how it works at least. This one missing 3 and 4 one. So this one's been there, there. So this it's got to be the one with the 3 in the front at the start of it. I'm hoping that I've got the method of this right. This will have to be the one with the 4 at the start. This will be the one with the 1 at the start. This one will be the one with the 4 at the start. This will be the one with the 1 at the start. Then we have the solution for this one and the other one. And hopefully if I've done that right, we can then just fill in half of the Latin hypercube. With that, this will be this one. So hopefully I've done this right. Okay. One, two, three, four. Three, 4, 1, 2. Let's do the next row. We have 3, 4, 1, 2, 1, 2, 3, 4, 4, 1, 2, 3. And 2. Are these all just in order? Yeah. 2, 3, 4, 1. I've done like the bottom 2 rows in each of them, which I think is still fine. Didn't realise that's the ones I ended up doing. So going to here should be 1, 2, 3, 4. 4, 3, 4, 1, 2. 2, 3, 4, 1. And 4, 1, 2, 3. Then 4, 1, 2, 3. 2, 3, 4, 1. 1, 2, 3, 4. And 3, 4, 1, 2. Three, 4, 1, 2. 1, 2, 3, 4. 4, 1, 2, 3. And 2, 3, 1, 4. Oh, 2, 3, 4, 1. Yeah. 2, 3, 4, 1. 4, 1, 2, 3. 3, 4, 1, 2. 2, 3, 4. Finally, 2, 3, 4, 1. 1, 4. 1, 2, 3. 3, 4. 1, 2. 1, 2, 3, 4. So we should, in reality, I think we probably will end up having it so just before I've filled in the entire thing, I think. Because some of them were already filled in, so. What do you think for? Three, 4, 1, 2. So it's probably going to. What's we going to solve soon? 2, 3, 4, 1. Maybe not. Maybe soon, and then this last row. Yeah, there we go. That's 2 scary ones dealt with. So yeah, that's that's good for me right now. Next time we're going to be looking at UIM plus L, and anything else past this might be simpler than what we just did there. Anti-memory is going to be an interesting one. We'll see when we get there. But channel surfing is soon, and as we go on to do with that. So until then, I'll see you later. Hope you enjoyed, and I'll see you later.